Hello everybody, today I'm going to discuss the molecule tetrahydrofurfurylamine. To begin with, we're going to talk about the molecular formula, which is C5H11NO. We have our 5 carbon atoms here, 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 and here. Then we have 11 hydrogen atoms, but not all of them are explicitly drawn. So I'm just going to indicate them with a black dot. So we have 2 right here bonded to this carbon 1, and then we have 2 more bonded to carbon 2, we have 2 more bonded to carbon 3, we have 1 bonded to carbon 4, and we have 2 more bonded to carbon 5. And then we have the 2 explicitly drawn hydrogen atoms that are bonded to this nitrogen right here. Next, we have the molecular weight, which is 101.1, and that is the sum of all the atomic masses of each atom present in this molecule. This molecule also has 1 degree of unsaturation, which are either the total number of rings and or pi bonds present in a molecule. This molecule only has a ring in it, so it has a degree of unsaturation of 1. We have 18 sigma bonds, which are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and then 2 more sigma bonds which connect the nitrogen and these 2 hydrogen atoms right here. We have no pi bonds because this molecule has no double or triple bond. Then we have our functional groups. The first one that I'll discuss is the primary amine, which is when a nitrogen is attached to a carbon and 2 other hydrogen atoms. And then we have our ether functional group, which is an oxygen that is connected to 2 carbon atoms with a single bond. The melting point for this molecule is 153 to 154 degrees Celsius, and that means it's a liquid at room temperature. We have 5 unique carbon groups that I'm going to show using green dots right here. So we have 1, 2, 3, 4, and 5. We have 6 unique hydrogen sets that I'm just going to highlight right here in blue. And we have 1, 2, 3, 4, 5. And then we also have to include the 2 hydrogens that are bonded to nitrogen because that's another unique set. We just have the notation right here, which shows this information that I just discussed. And then we have 3 lone pairs that I'm just going to show in red. We have 1, 2 single electrons that makes 1 lone pair, and then we have another one on oxygen, so oxygen has 2 lone pairs, and then we have our final one on nitrogen. Furthermore, we have 5 sp3 hybridized carbon atoms. All the carbon atoms in this molecule have sp3 hybridization, and we have no carbon atoms that are bonded to 3 hydrogens or 3 other carbon atoms. We only have CH2 and CH bonded carbons in this molecule. So we have 1, 2, 3, and 4 CH2 groups, and then we have 1 CH group right here. To create a model of the molecule tetrahydrofurfurylamine, we'll be using the Snatoms model kit. The black ones will represent carbon, the blue magnet will represent nitrogen, the red magnet will represent oxygen, and these white ones will represent hydrogen. I will begin creating the tetrahydrofurfurylamine model by first taking 2 carbon atoms and putting them together. I'll then do 2 more to create my ring, and finally I'll connect the oxygen, completing my ring. Then I'll connect my last carbon, creating the carbon chain, and connect my nitrogen to it in order to create my amine. I made my model using the Snatoms kit, and here I have my primary amine group, my NH2 connected to this carbon right here, and here I have my ether group, which is my oxygen connected to 2 different carbons. This carbon, this carbon, this carbon, and these carbons are all CH2, and this is a CH classification because it only has 1 hydrogen connected to it. And that's my model for tetrahydrofurfurylamine.